guys, in this video we're going to be working through an exam style question.
Hi guys, in this video we're going to be looking at an exam style question about rates, collision theory and catalysts. This question starts by reminding us that sodium will react with sulfuric acid in order to produce hydrogen gas, and we're given an equation for this reaction, which we can see has been balanced. This reaction is an example of the standard reaction between a metal and an acid in order to produce a salt and hydrogen. In part A, we're asked which one of these changes would increase the rate of the reaction, and we're told to circle one out of A, B, C and D. In order to answer this question, we need to think about the collision theory that we use to understand rates of reaction, and the different factors that can affect a reaction's rate. Let's look at each of these options in some detail. A says that we should use a more dilute concentration of sulfuric acid. The concentrations of reactants will affect the rate of a chemical reaction, because the rate of a reaction depends on the number of successful collisions between reactants in a given amount of time. And if the reactants are more concentrated, there'll be more collisions and therefore the rate of reaction will increase. However, using a more dilute concentration of sulfuric acid will decrease the rate, so this isn't the answer to the question that we've been asked here. When we're thinking about reactants that are in solution, we can consider their concentration and its effect on the rate of reaction. However, in this reaction, we're reacting the solution, sulfuric acid, with solid sodium, and we can therefore affect the rate of the reaction by changing the surface area to volume ratio of the sodium. This is because for a solid, the larger the surface area, the more collisions it will undergo with other reactant molecules, and therefore the more successful collisions and the more reactions that will take place in a unit time. Question B and C are both talking about changing the surface area to volume ratio of the sodium. B says that we should use smaller sized sodium metal pieces. Smaller sized pieces of sodium metal have the same volume but a larger surface area, and therefore we would expect that using smaller sized sodium metal pieces will increase the frequency of successful collisions between sodium and our other reactant, sulfuric acid, and therefore this will increase the rate of reaction. Part C suggests that we use sodium pieces with a smaller surface area.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.